Hello, dear participants. I wish you success on this organization, International Conference on Mechanical, Automotive, and Mechatronics Engineering. Dear participants, also today I want to talk about this presentation, performance of grid-connected hybrid power generation system, combining wind and solid oxide fuel cells with an ultracapacitor storage unit. This presentation, our introduction will be related to renewable energy system, wind and solar established technology, fluctuating output, and also fuel cell emerging technology, expensive solid oxide fuel cell slow response, and to maximizing benefits to enhance the reliability, different energy system are combined hybrid system. And also in this work, wind and solid oxide fuel cells, and they are combined together forming hybrid system in grid mode. Ultracapacitor used as storage system mitigate fluctuations in this presentation. Okay, here you see the system configuration, dear participants. In this figure, the schematic diagram you see the schematic block diagram of hybrid system, which is composed of solid oxide fuel cells, wind energy conversion system, and ultracapacitor. To connect solid oxide fuel cells to the common DC link you see, the boost converter is used while combination of boost converter and diode rectifier is used to connect wind system to the DC link. If you look at this figure, on the other hand, ultracapacitor is joined to the DC link through a bidirectional converter. All these components combined yields hybrid system that is intended to provide efficient energy conversion. The solid oxide fuel cells serves to convert chemical energy of fuel to the electrical energy, while the wind energy conversion system can do the same by directly converting. Okay, here you see control schemes, schematic of boost converter controller. The left side and right side you see schematic of bidirectional converter control system. Let's talk about results and discussion. We have limited time. You see grid parameters such as DC link, voltage, solid oxide parameters as rated power, 100 kilowatt, number of cell in series in stack. And DC link voltage here, 750 voltage. And you see other parameters, rated power, and poles, and wind turbine parameter. Here our rated power will be 55 kilowatt, and the wind speed is taken here between 6 and 12 meters per second. And you see also inertia, radius, and other wind turbine parameters. Also ultracapacitor parameters, rated power will be here 100 kilowatt, and capacitance you see 125 farad, and other parameters are given in this table. Okay, if you look at the results, dear friends, the behavior of solid oxide fuel cells when the load change without using, and also capacitor is demonstrated in this figure. The inverter references change from 10 kilowatt to 90 kilowatt at the time 2 seconds. And it can be observed that the power output by the solid oxide fuel cell takes some time to arrive at the desired level. And also we can say to meet the required power requirements, the grid is used to supply the load in the intern. And If you look at the other figures, you see link voltage without ultracapacitor and DC voltage with respect to time, and power variation at DC link. Dear participants, we can say the wind system solid oxide fuel cells, they are used together continuously to continuously generate necessary electricity for system. At 18 seconds, the wind speed is 6 meters per second, and solid oxide fuel cell is providing most of the power required. As the wind picks up, the power provided by the solid oxide fuel cells decreases at 20, 22, and 24 seconds. The wind speed increases to 8, 10, respectively, and 12 meters per second. And also the solid oxide fuel cells output correspondingly reduces. You see also here wind power, ultracapacitor power, and solid oxide fuel cell power variation at DC link with change in wind. You see with respect to time power variation. And also with ultracapacitor, you see power variation, charging of ultracapacitor. You see total power and solid oxide fuel cell power and wind power with respect to time. Again, you see here voltage value with respect to time and ultracapacitor terminal voltage with respect to time. You see the variation with respect to time. Again, power and wind speed are given in these figures, in this graph. Active power variation of inverter, load, and grid. Yeah, you see, again, they are given with respect to time. Okay, dear participants, we can say the solid oxide fuel cell is dispatchable power source, meaning its output can be scheduled. Unfortunately, solid oxide fuel cells has slow dynamic response to load change. So short-term compensation is needed during the transition period. Ultracapacitor, we can say they have higher power density, so they can be used to counterbalance the slow dynamics of solid oxide fuel cell. And this paper presents a solid oxide fuel cell and wind-based hybrid system with ultracapacitor and performance. You saw fluctuating power generated from wind systems, and it is effectively compensated for by combining solid oxide fuel cells and ultracapacitors. So, and the hybrid system, we can say it has better performance, and ultracapacitor is power dense device. It can supply only for short terms, durations, we can say. Here are the references. Dear past participants, thank you for your listening.